This is going to be our quick introduction to Biopython. So in about a week and a half, something, Dr. Korfa is going to come in and do 3 lectures, and he's going to talk a little bit more about bioinformatics, and he'll talk a little bit about some deep learning sorts of things. That'll be in a little while, and he'll get a little bit more into some of the various aspects of Biopython, but this is just sort of a quick intro to kind of show you how the package works. Biopython is another one of these very large packages which does lots and lots of different things. Not only will it do things like manipulate sequence data, but it can also do things like blast searches, and it can do things like PubMed queries and give you literature references and stuff. So it does really diverse sorts of things. However, the way it does all of these different things follows sort of a standard kind of paradigm. So if you understand how to use one of the tools, you can pretty easily understand the other tools. And I'll also point out that it has a very nice manual. So it has a nice kind of a tutorial style manual where it'll give you an example of how to do each thing that the library is capable of doing. Now before we get to that, I also have one other little aside topic here, which is scope. This is an important thing to understand and something we haven't really talked about so far. It can be very confusing if you don't understand how it works. So let's take a look at this little program here and see what it does. All right, so we define a function, we do a little math, we return a modified value. Then after we define the function, we set x to 5, we set y to 6, then we print y, we print f of x, and then we print y again. Okay, so x is 5, y is 6. We call the function, y is equal to x times 10, return y. All right, so y should obviously be 6. What is the third value going to be? All right, let's do it. Six. All right, why is it 6? When we get into this function, I'm setting y is equal to 60, and then I'm returning y. However, this function, this y here, only has meaning inside the function. The y that I've defined here is a global y. It exists in the Python, the global Python namespace. When I do something like define a function, I'm making a new namespace where all of the variables that I deal with in here only exist within this function. If I did something in here, like x is equal to 12, x is still going to be 5. Okay? Any variables that you define inside a function only have meaning in that function. As soon as you return, all of those things go away. So it won't modify anything. All right. That's our first scope case. How about this? I've defined a function, but the function doesn't take any parameters. And now I'm saying y is equal to x times 10. Same thing it did before. Didn't crash, it worked. Why? Well, Python is tricky. When you try to use a variable that hasn't been defined in the function, the first thing it does it looks to see if you have a value, right? If you have a parameter or something like that. If it doesn't find it, then it will look in the global namespace and see if a value is available there. This is very odd behavior for typical programming languages. Most programming languages don't do that kind of thing. Most languages will force you to pass it into the function or something like that. What would happen now here if I said x is equal to 3 or something? Okay, now it raises an error. It gets mad at me. Why did it get mad at me now? Well, here I'm defining a value for x. Here it didn't have the value for x there, but it recognized that in the function the value for x is being used later. So now it's saying it can't figure out what the heck you're trying to do. So it raised an error. Now, if we wanted to be a little bit clearer about what we were trying to accomplish here, there's another keyword that's available that we haven't learned before, which is global. So if you declare a variable as being global at the beginning of your function, then it will look at the global context, and now there's no error anymore, and now if we look at x after the loop exits, it's been changed to 3. So this is saying that the x that I'm using anywhere in this function is the global x, not a local x that I've defined. Okay? Now, this is not the end of our scope discussion. It's the beginning. So from what we've talked about here, we have the local scope, which is variables defined inside a function, and we have the global scope, which is the scope in our Python kernel as a whole. There are other scopes that can exist within Python. When you import data from a module, import stuff from a module, say when you import math has some variables defined, like the constants, pi, e, that sort of thing. Those variables may be available in the global context, but the global scope, but they are also defined at the module level. So there are variables that can exist independently at the module level from the global scope. And then later on in the term, we're going to talk a little bit about object-oriented programming, where we define objects. So like when we were dealing with images, those were image objects. We'll talk about how to define our own object types. And objects also have their own scope associated with them. So scope is kind of a tricky concept. It's something definitely to be aware of anytime you're defining functions or objects or that sort of thing. All right, we'll skip that and skip ahead to Biopython. So these are just a few of the things that Biopython lets you do. It's very good with sequence data. So if you go back to our first homework assignment where we did reverse complement of a sequence, it has built-in methods for doing reverse complements and doing transcoding and doing all sorts of stuff with sequence data. It also has capabilities for querying servers. You can access databases. You can do things like blast searches, all sorts of things like that built in. You can access PubMed and Medline for journal citations, and it has some simple GUI programs. There's integration with BioSQL, which is a database sort of system. This is sort of the source for the documentation for Biopython. So if you want the details, you can go there. We're just going to go through a couple of quick examples. So here is an easy example for querying the Swiss protein database. So what we're going to do, so this is the accession number for a particular protein in the Swiss prot database. So what we do here, we have to import the modules, of course. Then we say XPC, which is the module which deals with SwissProt and some of the other servers. We call the get sprot raw, which again is accessing sprot SwissProt, and the output that we want is just raw data. Then we give the accession number, and basically this gives us a file pointer. It's like a file pointer. In reality, it's a handle to a remote resource. So we create the handle. This opens the connection, and then here we read from the handle to get the actual data back. Then we close the handle at the end, and then we can look at what we got. Now, if we look at handle, it should be closed. Well, it's not going to say that it's closed, but it is closed. And if we look at sequence record, that should be the results that we got back from the server. And indeed. So when I just display it like this, it's going to print it out, sort of like it's a dictionary, but this is really just the way the object is representing itself on the screen. If I want to access any of these elements, the way I do it is I say sequence record dot, say I want the sequence itself, dot seq. Okay, and that gives me a sequence object. Now, what can I do with the sequence object? It looks kind of like a string, but it's not actually a string. It's actually a specific object type. What sorts of manipulations could I do? Let's use help. So when you use help, not only can you use help on methods that are built into the system, you can ask for help on instances of objects. So I don't have to figure out what the sequence class is. I can actually just ask for help on this particular sequence class. So I can say help on that, and it'll work. And you can see here, we can see all the different things that we can do here. Translate, transcribe, strip, starts with, split, r-split, reverse complement. So let's go ahead and try something. Let's try a, so I'm going to get rid of all this help content here. You can see it's a number of pages long. So let's try reverse complement. There you go. There's the reverse complement. So easy homework one, right? Anyway, so those records, you can get access to all of the various fields that are present in the database, and you know, basically you've got all the information that you get from the query in a nice, easy-to-use form. Here's another example. This is an example of running a BLAST query. We'll go ahead and do it, although this may take a few. So when you're running a BLAST query, it's actually using their server to do the BLAST search itself. So the amount of time it takes will depend on how busy the server is. So we'll see. It shouldn't take more than a few seconds, I think, typically. Maybe we'll talk about the next one while this is running. Yeah, it's taking longer than usual. All right, let's go on to the next example while we're waiting for that. PubMed is probably one of the most widely used things for sort of generic student. Not all students are going to be doing sequence manipulation stuff in their research. Pretty much everyone needs to do PubMed queries at one time or another. And this gives you more power than you get from the web-based interface to PubMed. This allows you to query the database in very specific and complicated sorts of ways. So let's see if it's still running. Wow. All right, let's go ahead and give this a shot. This won't take a long time because it's just a straight database query. There's no computation involved. Oh, it finished, of course. All right, again, this is the same sort of strategy. This is opening a handle object, basically, and then you're reading from the handle object, and then we're closing the handle object, and then we're looking at the list of results. So we got a whole bunch of alignments out of this. So let's look at the first one and see what we've got. Well, that's not very insightful, is it? It's an alignment record. It doesn't display itself in a very useful way. So let's do help. All right, what does this have? Well, it's got a bunch of methods in here. If we go up to the top, let's see. Oh, sorry, I didn't want alignments. I wanted that was a list that we got help on. Okay, there. So these are the fields that it has internally. A title, hit ID, hit definition, length, etc. And then a bunch of HSP objects. So the title will give us some information. So let's say .title. Okay, there we go. And this is GrowEL. And indeed, the sequence information that I used there was the sequence from a chunk of GrowEL. Okay, so it found GrowEL. Let's see what number 1 is. So it had a whole bunch of matches. So that's also GrowEL, but from a different organism. 2 looks like another GrowEL from a slightly different species. So anyway, you can see the BLAST query did what it was supposed to do. All right, now on to our PubMed example. Okay, so what are we doing here? So when you're querying NCBI, there's this email field. So when you say entree.email, this will set your email address. Please don't copy my example and use my email address when you do this. And when you submit the request to the server, your email goes along with it. The reason for that is if you write a program which does a whole bunch of queries on PubMed, like you try to retrieve the entire PubMed data space or something like that, and it's it's hurting their servers. It's overwhelming the servers. These are government machines. They're old. They're out of date. They're susceptible to that kind of problem. If you don't provide your email address, they may blacklist you. They may blacklist your IP address. They could blacklist all of Baylor if they're feeling particularly aggressive. If you give them your email address, they will try and contact you by email and tell you, hey, what you're doing is messing up our database, rather than just blacklisting you. So you're always supposed to provide your email whenever you use NCBI. Okay, so then again, we create this search object. I'm just doing a basic search for myself as author. You have to set the maximum number of records you want it to return. Then we're just reading from the handle like we were doing before and closing it. Now, let's do this as two separate things. Let me get rid of that part. We'll just do this first. Okay, so there we've got 107 records. Then here the ID list. These are the PubMed IDs of all the matching entries. So the next part of the code would be this, which is looking at the ID list, extracting the ID list from here, and then we can retrieve the detailed entries for, say, the first two entries, right? So ID number 0, ID number 1. And now if we look at records, we can see, so there's the first PubMed ID, there's the name of the article, the extension, the DOI for the article, full abstract, all those parameters. And all these parameters are represented basically as sort of a Python dictionary, so you can do all sorts of complicated things that would be really hard to do using the online PubMed query mechanism. So you can use the power of Python to deal with the results that you get out. I will point out that this is, usually every year I have one or two people who use this as a basis for their class projects. They come up with some interesting sort of thing they can do using this mechanism as opposed to the web-based mechanism. This is also a nice way, if you're thinking about doing a rotational lab, something like that. This is a nice tool you can use to sort of look at the publication history. You can use it to reference, what other groups has your PI collaborated with, or potential PI collaborated with, that sort of thing. Now, of course, you're probably all familiar that the fact that PubMed is kind of kludgy to use. It's not really all that friendly. And there are other things like, say, Google Scholar, which may be a little bit more friendly. Unfortunately, there's no official API programming interface for accessing Google Scholar data. But there are some unofficial ones out there. So here are a few interfaces to Google Scholar which sort of scrape Google Scholar to pull information out. Again, you have to be a little careful with this that you don't get too aggressive about it, because Google can blacklist you from Scholar as well if you're downloading millions of records and it looks like you're trying to clone their database or something like that. But generally speaking, you're not going to have too many problems. If you're not familiar with Google Scholar, it's a very useful tool. You'll find that most PIs will have set up their own profiles in Google Scholar, and the sorts of things that it will give you that you won't get out of, say, a PubMed query are things like citation counts. So you can see citation counts not only for individual papers, but also, sort of the PI over time and that sort of thing. And that's the sort of thing that you can also use if you're trying to sort of judge whether your PI is early career, late career, mid-career kind of thing. Sometimes you can tell it's assistant professor, associate professor, full professor, but that's not always all that robust, this sort of thing. But these are the sort of statistics that also get looked at when people are applying for tenure and that sort of thing. So you can get lots of useful information out of Google Scholar. Even if they haven't set up a profile, you can still get lots of good stuff there. Just point out that these are the official names for so PubMed is sort of a derivative of Medline, which is the database they originally set up for medical journals. So first it was a medical journal database in the very early days of the NIH. And then they sort of expanded to sort of cover all biological research, and now it's sort of expanded outside of biological research. Anyway, you'll notice here, here, when we did this query, we got back these various, DEP, PL, TA, JT, all of that stuff. This is the definition of all of those terms. So the abbreviation that it's going to use when it returns them as database entry is going to look like this, and you can then translate those into what they actually mean. It's usually obvious, but sometimes it may not be completely clear what some of these terms are. Like what's EDAT, right? What is that date specifically? So that's the entree date. So that's the date that it was added to the database. That sort of thing. So there's another Python statement which we haven't looked at before, which is a good sort of safety mechanism you can use when you're dealing with external databases and web queries and stuff like that. And that's the with statement. So if you look here, previously I said handle equals entree.esearch blah. Here I'm saying with entree.esearch blah as handle. Okay, this is basically the equivalent of an equal statement, where this is the left side and this is the right side, so it's a flipped around equal statement. But with marks the beginning of a block. What this does is it sets handle to be equal to the results of this function call, but only as long as this block exists. So as soon as we leave the block, it will automatically close the connection. So if you use this with statement to open a file or open a connection to a remote server or something like that, you don't have to worry about explicitly closing the connection. A common problem that you find when people write code is they'll write code that opens a connection, and then there's some error that it catches in the middle. And when it catches the error, they forget to close it, and then they leave the loop, and the connection stays open forever or something like that. If you use with, then as soon as you leave the loop, if it's because of an error or if it's because it naturally exited, whatever, it'll automatically get rid of that remote connection. So with is actually a really good thing to use when you're using some of these resources. You don't have to, you can always close it manually, that's fine, but it's a good convenience function.